We are now beginning to discuss theories of biological origins, from the origin of life to how all groups of animals originated. Theories of biological origins can be divided into 4 parts. First of all, there's the origin of life. How do we get from a non-living world to life? Then there are microevolution and speciation. And the 4th category is macroevolution, the origin of new organs and new body plans, new kinds of animals. The upper part of this diagram is an illustration of microevolution and speciation, and then the lower part is diagramming the theory of the evolution of all types of organisms from a common ancestor. The origin of life simply deals with how do we get from non-living chemicals to the amazing complexity of a living cell. For the origin of life, there are really just 2 options. One is creation by an intelligent inventor, an intelligent creator. Number 2, abiogenesis, also called chemical evolution, is the origin of life from non-living material with no intelligent intervention, no creator involved. Abiogenesis will occur only by chance chemical reactions. Once we have life, then we can talk about how life changes. And first of all, we have microevolution, which is referring to change within a species, adaptation to changing environments. Here we have the same species of lizard. They've adapted to 2 different environments, and so they look different, but they're still the same species. The definition I gave, change within a species, is the standard definition, but it's really not quite adequate. Changes within genera, and maybe even some families, are the same genetic process as microevolution. So here we have 4 genera of squirrels in the family Sciuridae. Possibly this should be called microevolution, but that will be controversial. Speciation is dividing a population into 2 populations that do not normally interbreed, and thus are new separate species, like these 2 species of chipmunk. They're very similar, but they don't interbreed, so they are different species. Macroevolution is the evolution of the higher categories of life. As we see here in this diagram, the origin of orders, classes, and phyla. In other words, different body plans. So how is macroevolution different from microevolution? Are they really different? They are really quite different. Microevolution is variation within an existing gene pool. There is no need to evolve new organs or new gene complexes or new physiological systems. It's just adaptation of existing animal to new circumstances. This can happen really rather quickly. Whereas macroevolution would involve the evolution of new genes, new organs, new physiological systems, new body plans. Macroevolution, by random mutations, must invent all of these new features. How is macroevolution different from microevolution? Are they really different? Some biologists would argue that macroevolution is nothing more than an accumulation of lots of microevolution. Is that true? No, I will argue that it is not true. These are really fundamentally different processes.